Okay, good afternoon. So this is Mr. Mosier, and I can't be with you during class today, but we're still going to take a look at 4.5 using graphs to estimate values. So what I'm going to do with this is I want to figure out which equation actually matches the line on my graph. So I'm going to take each equation and I'm going to solve it for my slope, y-intercept form, which if we recall is y equals mx plus b. All right, so let's take our first one. We're going to take our x here, we're going to move it to the other side, over into this area. So we're going to get minus y equals, well, negative x plus 4. Now I need to multiply both sides by negative in order to get rid of the negative on this side with the y. So this is multiplying both sides. It gives me y equals, well, this is x minus 4. Okay, well, in this case, I know that I have a slope, or m, which is equal to 1 over 1. Well, and I have a b value that's equal to minus 4. So my b value is my y-intercept. So if I take a look here, well, that one doesn't work because it's off my graph. All right, so let's take a look at the second one. All right, so here I've got x minus 4y equals 4. So again, I'm going to take the x and I want to bring it over to the other side. So I'm going to get minus 4y is equal to minus x plus 4. All right, so let's see what we get. So I now need to take this minus 4 over, and I'm going to divide by it. So I'm going to get y is equal to, well, minus x over minus 4, plus I'm going to get this 4 divided by a negative 4. Okay, so let's start with the first part. Y equals, well, negative over negative for the x over 4 gives me a positive. X over 4 really just means 1 over 4x. And if I look at this next part, the 4 over negative 4, well, positive divided by negative is going to give me a negative. 4 over 4 gives me 1. So I know for this one here that I have a slope m, okay, of 1 over 4, which is my rise over run. And I have a b value that's equal to negative 1. Okay, so let's take a look. So on my graph here, I know that b equals negative 1. So that's going to be my y-intercept. Okay, now I have a rise and a run of 1 over 4. So let's see what happens. So if I do a rise of 1 and a run of 4, I get to my next point. Now remember that because this is 1 over 4, they're both positive, I could also put my slope as minus 1 over minus 4. Now, that still is equal to a positive 1/4, but notice this. So for my rise, I could go down 1, I could go back 4, and I'm going to get my other point that's on my line. So in this case here, this is equal to, for my graph, this is x minus 4y equals 4. So this is x minus 4y is equal to 4. All right, now there's still a chance that maybe this other equation is the same as that b one. So let's take a look at it. We're going to take this and we're going to rearrange it. So minus y is equal to minus 4x plus 1. Multiply everything by negative to get y all by itself, and I get a positive. Actually, I don't have to write the positive, do I? I can just write 4x minus 1. So here I know that I have a slope value of 4 over 1. Remember, rise over run. And if I don't have a number under 4, I can just put 1. And I have a b value that's equal to negative 1. Well, on my graph, this does work when I look at my b value, negative 1. But notice that my slope is 4 over 1. So that's a rise of 4 and a run of 1. So that would be like going 1, 2, 3, 4, and over 1. So my other point would be up here. So we know that that one cannot be right. So again, it still stays with b. X minus 4y equals 4. Okay, so when I look at math here, the graphs are very useful ways to organize your information. Okay? It's something that we can see. Now this says sometimes we can just use the graph to answer our questions directly and not worry about an equation, and we have two different processes here. So the first one is what we call interpolation. I can never say that word right, interpolation. And this is basically, so estimating, okay, a value inside a set of data points. Okay, so what that pretty much means is that I'm going to be looking where I actually have data. If I go back up to this one, so if I'm looking up here, I would be looking, somewhere between this line here and this line over here. All in between here is where I would be looking for information. So that's interpolation, so it's inside of what I know. Now my other one here, which is extrapolation, that one I can actually say a lot better. Extrapolating is almost the same. So this is estimating a value, okay, inside a set, sorry, that's not right. See, I just started copying the one from up above. Estimating a value outside a set of data points. Okay. So if I'm thinking about this, I'm going to clean that up a little bit just because I want to. That means that if my graph was big enough up here, I could actually look beyond the points that I already know. So let's take a look at the next page and see what this is going to look like. All right, so here we have a linear relation. Okay. Now it says, is this interpolation or extrapolation? So it says determine the value of x for each value of y. Okay, so for this value here, y is equal to 3. Well, all I'm going to do is go up here to where y is equal to 3, and I'm going to look over, and I'm going to find my point. Well, in this case here, x is equal to 1. Now, let's take a look at this next one. Okay, so for this one, I've got y equals minus 2. Okay, well, let's see y again. Y at minus 2. And I go over here to where I find my point. Well, in this case here, it looks like it's about minus 1.5. Would be pretty quick. So that's what x is equal to. Now this last piece, it says when y is equal to 7. Okay, well, y equals 7. If I take a look at my graph here, I'll notice that for my graph, it does not go up to 7 on the y. So let's fix that. So I'm going to add in this piece. We're going to say that this is 6. Now, I know that when y is 7 then, I have to find out when does it meet up here when y is equal to 7. So I'm going to grab my ruler here, and we're going to take a look at this. So I'm going to put this here down on my point. And let's take this and we'll just sort of match it up a little. This will be pretty close. So here we've got extending it this way. Now I'm going to pull this down. I might as well extend it in the other direction also. So let's do that right away. Okay, and let's put this thing here back to being straight. Whoop. Okay. So, and we're going to put this right along here, and we're going to draw from this side, and we're going to draw from this side. Okay. So now that we've taken our lines and we've extended them, okay, So I know here that then this is going to be 2, 3, and 4. So it looks like when y is equal to 7, that my x value, which is right here, is going to equal 3. So this is going to be when x is equal to 3. So let's add into this then, what is it that exactly we're doing? So it says, is this interpolation or extrapolation? Well, the first one here, this is inside, okay, of my data point, so it's interpolation. The second one is also inside the data that I already had on that black line. So my last one, though, I had to look past what I knew. And in this case here, then, this is extrapolation, or we'll use E for it. All right, so let's take a look at this next part. It says, determine the value of y for each value of x. So now we're going to look for when x is equal to 0, what is y? All right, so bringing down my graph here. When x is equal to 0, well, it looks like I get 1. So y is equal to 1. And again, now this is interpolation. So let's take a look. We want to know for our second one here, when x is equal to -2. All right, so coming down here to -2, and I look all the way down here, and I find out that x is equal to y is equal to -3. And again, this is inside the information I already know, my data set, so it's interpolation. Now I want to know when x is equal to -4. Well, I'd have to add something on here then, because I need to know here when x is actually equal to -4. Now we've already extended our graph, so if I take a look at this, when x is equal to 4 over here, if I go all the way down, this is what I get. Well, there's my point. I forgot to sort of take this one here and extend it. So let's extend it now. I'm going to put -6 right here. So it looks like when x is -4, right, that I'm going to get the fact that I've got y is equal to -7. So y equals -7. And again now, this is outside of the information I already knew, so it's extrapolation. Okay, let's take a look at this, I believe, last one here. Okay, so a little bit too far. So this says the graph shows how the cost of a long distance call changes with the time for the call that we have. So let's take this out of here. Of course, with all of our information that we have nowadays, it doesn't really cost us anything for a long distance call on a cell phone. Now this says, though, estimate the cost of a 7-minute call. Okay, well, 7-minute phone call, okay, is what I'm looking for. Let's actually get a pen here. So I'm looking for this 7-minute call. So on my graph, what I'm going to do is I'm going to find where x is equal to 7, and I'm going to go straight up here, okay? And I know that this then is somewhere in about here. Now, for each one of my blocks here, I've got 1, 2, 3, 4, 5. So each one's worth about 5, okay? So I would have to estimate somewhere that the cost of this phone call, actually, let's put that up where it goes, that the cost of my phone call, so the cost is going to equal about, let's say, 55 cents, okay? So 0.55, and that's what it's going to cost me. Now again, remember, I'm already given some information on this graph, okay, with the line that I have. So because it's already there and I can see it, this is interpolation. Okay. All right, so it says for part B, the cost of a call was $1. Estimate the time for the call. All right, well, let's take a look here. If I know the cost of my call was $1, okay, so I'm going to take here, and at $1, I'm actually going to draw a line, and I'm going to go over like this, okay? Now, I need another line to extend my graph. So my extension for this thing, okay, I'm going to start back here a little bit so I can make sure that I'm sort of on my line, and now this is what I've got. So in this case here, when I extend these two, I get a point that's right here. All right, well, I need to then probably extend the bottom of this graph just a small amount, okay? So I'm going to extend this one here over to here, okay? And I know that if I'm looking sort of straight down here, okay, that I can look at a value. So I've got 10, I've got 11, 12, 13, so this is at 14 in here. So I know that a $1 call, okay, the estimated time is 14 minutes, okay, and this is by extrapolation. Okay. And again, because when I take a look at this, my data is outside what I already knew. Now this says the cost of a phone call was $1.50, estimate the time of the call, and this is for part C. So in this case here, I've got to do a little bit more extending. So I'm going to extend this top line here for my cost. I'm going to bring it all the way up to the top here. And if I was to put in some numbers, so I'm going to just count here. So I've got, this is 10, 20, 30, 40, 50. So right at the top, this is where my $1.50 is going to be. So that means that when I take and I extend my graph in this one, I'm going to go from here. So I'm going to extend it over quite a ways, okay? And then I'm going to extend the graph line that I already have. So with my graph line, right, so we can extend this thing right up like so. Okay. So what do I get? Well, let's move this over a little bit. I then have to take right at the very bottom here on my timeline, okay, or my time scale, and I'm going to have to extend this one here again a little bit more. So this is what I've got. So going ahead and counting with this, it means that I have, let's take a look up here, I've got 14 already there, so 15, 16, 17, 18, 19, 20, 21. So this is at 22 minutes. All right, so if that's 22 minutes, that's right there, of course, and this is, oh wow, that lights up quite a bit in there. So I know that for $1.50, okay, cost of it, that the time is going to be 22 minutes, okay? So the estimated, and I have to put estimated here, okay? I don't want to put exact because we could be wrong a tiny bit somewhere. It might be off a little bit. But the estimated, okay, time is 22 minutes. And again, this is extrapolation. Oh my goodness. Okay, let me start that word all over again because you guys know how my writing goes some days. So let's try this again. So, extrapolation. Okay, so that is the end of it. And for your assignment, okay, we're going to take a look at pages 196, and you've got 4, 7, 8, 9, 11, and 13. Okay? So at this point here, you also have some work maybe left over from 4.4 and 4.3. Okay? So I would like this to be due on Friday. All right. That's it. Have a great rest of your day, and we will probably see you tomorrow.